Hello, everybody. I hope you guys are having a great day. We are going to start our next unit today, and we're going to start by doing a warm-up over proportions, okay? So make sure you're cross-multiplying, distributing through, and then solving. So go ahead and take a couple of minutes to find your answers for this. Okay, so we are moving on to the triangle proportionality theorem, and I'm thinking you're going to think that this is a fairly simple thing. Again, we are using proportions, notice proportionality, so you are still going to have to be doing some of that cross multiplying to be able to solve. Okay, so what is the triangle proportionality theorem? Okay, say that 3 times fast, it's really hard. Anyway, if you draw a line constructed parallel to one side of the triangle intersects the other, okay, it divides them proportionally. So this is what it would look like. And the line that was drawn was CE, okay? And what this rule says is that by doing that, then we're saying SC and CL are proportional and SE and EI are proportional, okay? And this little colon means also fractional, okay? Ratio, fractional, proportional, it's all the same terminology. So basically it's just saying however you split it, you're splitting it into something that is a proportional side, okay? So here is an example. It is saying that QS and SP are proportional to RT and TP. Okay, and so we need to set that up and solve for X. So I am actually going to pull up my other screen here. If I can get it going here. Sorry about that. Let me get this up. Here we go. All right, and let me scroll in here. You'll have to excuse my scribbles. All right, so basically it is saying that this side and this side are proportional to this side and this side. So to set that up, we would say 2 to 6, x to 9, and now we have our proportion, and now we're going to cross multiply and solve it. So we have 6 times x, which is 6x, 2 times 9, which is 18, divide by 6, and we get 3. So we're saying that this part of that proportion is 3, okay? Here is another way to look at it. Okay, another way to look at it. And again, we're going to do the exact same thing. So let me again pull this up. We are saying that this side and this side are proportional to this side and this side, okay? And one thing you need to pay attention to is this whole thing is 28, which makes this part of it 20. So that 20 plus 8 is 28. And we're still going to set it up in that same proportional way. So we're going to say 10 over 3x minus 5 is equal to 20 over 8. Okay? And now we're going to cross multiply and solve. So remember, this has to be distributed. This is 20 times 3x minus 5. And 10 times 8 is 80. Remember, when you have that, you have to distribute this through. So 20 times 3 is 60. 20 times 5 is 100. Now we are going to add 100. And we'll get 60x is equal to 180. Divide by 60, and x is equal to 3. So that tells us 3 times 3 is 9, right? And that would solve our problem for us. That gives us x. Okay, but in this case, it doesn't have you plug it back in, just has you solve for x. Alrighty? So you guys, using that same thought process, you guys go ahead and solve this one, set your proportion up, and see what you get for x. Okay, so now try it for this one. Again, this one, because it has this x plus 2, you're going to have to do some distribution. So go ahead and set up your proportion and solve for x on this one. Okay, so the second part of this is being able to use the converse of this theorem. And it basically says that if you cut this in half or use it and separate it into proportional sides, then the two ratios have to be equal to each other. So basically, it's kind of like scale factor where we've been seeing if they match up. That's basically what it's asking. So it's saying if this truly is proportional, then this side, RT and TQ, will be equal to RU over US, okay? So the gist of that is something like this. Okay, here's our problem. It's asking us, are these parallel? And the way you set that up is just to say, does this over this equal this over this? Okay, so is 21 over 7 equal to 24 over 8? Well, you'll notice 21 over 7 is 3, 24 over 8 is 3. Yes, 3 is equal to 3. So yes, these two lines are parallel to each other. Okay, that's as simple as it can be. Another way you could do that, if it doesn't divide evenly, is to cross multiply it. So we would take 7 times 24 and we would get 168. And we would take 8 times 21 and we would get 168. So that would show you as well. The two proportions cross multiplied are equal to each other. Okay, so let's look at another one. Okay, what do we do in this case? Are these parallel? So again, we are going to have to set our proportions equal to each other. So we're looking at this and this, and this and this. Are those equal? So we would say 16 over 8, 12 over 6. Okay, you can see that this is 2 and this is 2, so you would already know. But if again, you want to cross multiply, you would see that 8 times 12 is 96 and 6 times 16 is 96. So yes, those are parallel. Okay. So lastly, you are going to do this on your own. You're going to see if you can figure out if these two lines are parallel. Are BE and CD parallel? So set up your proportions and see if they are equal to each other. Okay, so hopefully you guys felt like today's was super simple. Obviously, this is a really fast ed puzzle, so the concepts are fairly straightforward, especially because we've already been talking about proportionality. So what you need to get accomplished now, there is a 3-question exit ticket for you to work on, and you do need to score a 3 out of 3 for credit. So go ahead and work on that and get that done, practicing these skills that you just learned. Okay, have a fantastic day and make sure you're coming to office hours and reaching out to me if you have any questions.